What if everything you think you know about reality is just a tiny fragment of something far grander, stranger, and more incomprehensible? Picture this: our universe, with its billions of galaxies, might be nothing more than a single drop in an endless cosmic ocean. Scientists call this mind-bending idea the multiverse theory, and it suggests that our reality is just one of countless others, each with its own laws of physics, histories, and even versions of you. Somewhere out there in another universe, you might be living a completely different life, or perhaps you don't exist at all. The sheer scale of this possibility is enough to make your head spin. But what if I told you the multiverse isn't just science fiction? What if the secrets hiding within this theory could rewrite our understanding of existence itself? Today, we're diving deep into one of the most provocative ideas in modern science, the multiverse. From parallel worlds colliding to alternate timelines branching off with every decision you make, the multiverse theory isn't just about multiple universes, it's about the very fabric of reality unraveling before our eyes. And the most shocking part, some of the greatest minds in physics believe there's real evidence pointing toward its existence. Think about that for a second. The universe, or should I say universes, might be far stranger, wilder, and more unpredictable than we ever dared to imagine. But how much of this is fact and how much is speculation? What do these infinite realities mean for our place in the cosmos? That's exactly what we're exploring in this video: 30 shocking secrets about the multiverse theory that will challenge everything you thought you knew. We'll uncover hidden experiments that hint at parallel dimensions, examine bizarre quantum phenomena that defy logic, and even explore whether the multiverse could hold the key to mysteries like dark matter and the origins of existence itself. By the time we're done, you might never look at reality the same way again. So, if you're ready to step beyond the limits of our universe and into the unknown, let's begin this journey, because what lies ahead is more extraordinary than fiction. The idea that our universe isn't alone, that it's just one bubble floating in an endless sea of realities, isn't some wild fantasy. It's a serious scientific hypothesis with roots stretching back decades. At the heart of it all lies quantum mechanics, the bizarre rulebook governing particles at the smallest scales. In the 1950s, a young physicist named Hugh Everett proposed something radical. Every time a quantum event unfolds, like an electron deciding where to be, the universe doesn't just pick one outcome. It splits. Imagine a fork in the road where instead of choosing a path, reality takes both, spawning two separate worlds where each possibility plays out. That's the many worlds interpretation, and it's one of the earliest blueprints for the multiverse. But here's where things get even stranger. Some cosmologists argue that universes could arise naturally from the chaos of the Big Bang, like bubbles forming in a boiling pot. Each one inflates with its own unique physics. Maybe in one, gravity is stronger, or light moves slower, or atoms never even clump together to form stars. This isn't just speculation, it's a consequence of theories like cosmic inflation, which describe how our universe expanded faster than light in its earliest moments. If space can stretch that way once, why couldn't it happen over and over, birthing endless pockets of reality? Of course, not everyone buys into this. Critics call the multiverse untestable, more philosophy than science. After all, if these other universes are forever out of reach, how do we prove they exist? But supporters counter with clues hidden in the cosmic microwave background, the afterglow of the Big Bang. Some argue unusual patterns in this ancient light could be bruises from collisions with neighboring universes. Others point to the eerie fine-tuning of our own cosmos. Why do constants like the strength of gravity seem perfectly dialed for life? One answer: we just got lucky in an infinite lottery, one winning ticket among countless universes where life never stood a chance. Think about that for a moment. The same equations that explain why apples fall from trees might also predict a reality where apples float upward or where trees don't exist at all. Hugh Everett's ideas were mocked in his time, but today they're at the forefront of physics' biggest debates. Whether the multiverse is real or not, the mere possibility forces us to ask, what is reality really? And if there are infinite versions of it, where do we fit in? Imagine waking up one morning to discover your life had taken a completely different path, one where you said yes to that job offer across the country, or where you never met your best friend, or where you became the person you once dreamed of being as a child. According to the multiverse theory, those versions of you aren't just daydreams. They could be real, living out their lives in universes parallel to ours. Every choice you've ever made, from the smallest like hitting snooze, to the biggest like who you married, might have spawned another reality where you took the opposite path. The implications aren't just scientific, they're deeply personal. Somewhere out there, a version of you might be a celebrated artist, while another is a recluse in the mountains. One might be a hero, another a villain, but how does this actually work? Think of reality like a constantly branching tree. At every moment of decision, the universe doesn't just follow one path, it splits, creating new timelines where every possible outcome unfolds. Missed a train in one universe, you caught it and met your soulmate on board. Turned left instead of right in another, that choice led you to an accident or a miracle. The unsettling beauty of this idea is that nothing is truly lost. Every road not taken in this world becomes someone else's reality elsewhere. Now here's where it gets even weirder. These alternate yous aren't just carbon copies with different haircuts. Their lives could diverge radically based on tiny, early differences. Maybe in one universe, your childhood fear of spiders led you to become a biologist, while in another, a traumatic event pushed you into a life of crime. The billionaire version of you might exist because of a single lucky break, a lottery ticket, a chance encounter, while another version struggles in poverty. The multiverse doesn't just suggest infinite possibilities, it implies infinite identities, each shaped by the randomness of their own world. This raises a haunting question. If there are countless versions of you, which one is the real you? Philosophers call this the problem of personal identity, and it's as unsettling as it is fascinating. Are you just the sum of your choices, or is there some core self that stays constant across universes? And if so, how would you even know? But let's ground this in something tangible. Take a mundane moment like scrolling through your phone right now. In another universe, you might have put it down and started a conversation that changed your life. In another, you dropped it, shattering the screen and altering your entire week. These tiny forks in the road might seem insignificant, but in the grand web of the multiverse, they're the stitches weaving infinite realities together. So the next time you wonder, what if, remember somewhere, somehow, that what if is already happening. Now, let's talk about a phenomenon so delicate yet so powerful, it can rewrite entire realities, the butterfly effect. You've probably heard the saying that a butterfly flapping its wings in Brazil could set off a tornado in Texas. But in the multiverse, this isn't just a poetic metaphor, it's the law of the land. Tiny, seemingly insignificant changes in one universe can ripple outward, creating realities so different they might as well be alien worlds. Think about the film Sliding Doors, where missing a train by seconds splits a woman's life into two radically different paths. That's the butterfly effect in action, except in the multiverse. It's happening everywhere, all the time, on a scale beyond comprehension. Take something as simple as a rainstorm. In our universe, maybe you forgot your umbrella and got soaked, leading to a cold that made you cancel a date. But in another reality, you remembered it, stayed dry, and ended up meeting the love of your life at that very same cafe. Now zoom out. What if 65 million years ago that infamous asteroid missed Earth? Dinosaurs might still rule the planet, and mammals, including humans, could have remained tiny creatures scurrying in the shadows. No pyramids, no space travel, no you. That's the staggering power of the butterfly effect across universes. A single cosmic event rewrites the entire script of existence. Chaos theory tells us that even the most predictable systems are sensitive to their starting conditions. A fraction of a degree warmer in Earth's early atmosphere, a single gene mutating differently in your ancestors. These microscopic shifts cascade into entirely new worlds. Some physicists argue that this isn't just possible but inevitable in the multiverse. For every universe where history unfolded as we know it, there are countless others where Napoleon won at Waterloo, where the Library of Alexandria never burned, or where electricity remained undiscovered. Here's the mind-bending part. These alternate timelines aren't just different, they're necessary. Without them, the sheer improbability of our universe's existence becomes inexplicable. Why do we live in a reality where Earth is just the right distance from the Sun, where oxygen just enough to breathe? The multiverse answers, because in an infinite sea of possibilities, some universe had to get lucky. And if that's true, then every choice you make isn't just shaping your life. It's spawning new branches of reality where every what-if plays out in full. So the next time you hesitate over a decision, remember, somewhere in another universe, a version of you didn't, and that split-second difference might have changed everything. What if death isn't the end, or even inevitable? The quantum suicide thought experiment takes the multiverse theory to its most chilling extreme, suggesting that your consciousness might never experience true oblivion. Picture this, a modified version of Schrödinger's famous cat experiment, but instead of a cat in a box, you are the subject. A gun is rigged to a quantum trigger, a radioactive atom with a 50% chance of decaying within a minute. If it decays, the gun fires. If not, nothing happens. In our universe, this seems like a gruesome game of Russian roulette, but in the multiverse, something far stranger occurs. Every time the trigger is pulled, reality splits. In one branch, the gun fires and that version of you dies, but in another, the atom doesn't decay and you survive. Repeat this experiment enough times and an eerie pattern emerges. From your perspective, you'd always find yourself in a universe where the gun never fires. No matter how improbable the odds, your consciousness would only ever experience the timelines where you live. This is quantum immortality, the idea that your subjective experience might never encounter death, because in the branches where you perish, there's no you left to observe it. Schrödinger's cat was a paradox meant to highlight the absurdity of quantum superposition. The notion that a particle, or in this case a cat, could be simultaneously alive and dead until observed. But apply that to human consciousness and the implications become deeply unsettling. If the many worlds interpretation is correct, does that mean we're all, in some sense, immortal? Or is this just a trick of perspective, a glitch in how we perceive probability? Critics argue this borders on pseudoscience, a desperate attempt to twist quantum mechanics into wishful thinking. After all, we see people die every day, but supporters counter that we only witness other people's deaths, never our own. Could it be that those who beat the odds in near-death experiences aren't just lucky, but subtly slipping into branches where they survive? The debate rages on, with some physicists dismissing it as philosophy masquerading as physics, while others insist it's a legitimate, if terrifying, consequence of the math. Here's where it gets even stranger. If quantum immortality is real, it might explain why the universe seems so finely tuned for life. From your perspective, you'd always find yourself in a reality where Earth exists, where the constants of physics allow consciousness to emerge, because in the branches where they don't, there's no one to ask the question. It's a cosmic version of survivor bias, where the mere act of being alive filters out all the universes where you're not. So where does that leave us? Staring into the abyss of a theory that's equal parts profound and horrifying. Whether quantum immortality is a quirk of probability or a fundamental truth, it forces us to ask, What does it mean to exist in a multiverse where death might just be someone else's reality? Hugh Everett's many worlds interpretation doesn't just suggest that alternate universes exist, it demands them. Every time a quantum particle faces a choice, like whether to spin left or right, reality doesn't pick one outcome. It splits, creating two new worlds where both possibilities happen simultaneously. Think of it like a choose-your-own adventure book where every possible ending is real, playing out in parallel universes you'll never see. This isn't science fiction, it's a direct consequence of the math behind quantum mechanics. But here's the catch. If every quantum decision spawns a new universe, then right now, as you watch this, countless versions of you are being born in realities where every conceivable outcome unfolds. Now contrast this with the Copenhagen interpretation, the older, more traditional view of quantum mechanics. In that model, particles exist in a haze of probabilities until someone observes them, forcing reality to collapse into a single outcome. It's like rolling a die but only seeing the result when you look. Until then, the die is all numbers at once, but Everett rejected this idea. To him, there's no collapse, no mystical role for observers. Instead, the universe divides, with each possibility getting its own reality. One universe where the die lands on 6, another where it's 1, and so on, ad infinitum. The implications are staggering. Under the many worlds interpretation, history isn't a single thread, it's a woven tapestry of every possible event. A world where the dinosaurs never went extinct branches off from one where they did. A universe where you took that job offer last year spins away from this one where you stayed put. Even the tiniest quantum fluctuations, like an atom decaying a millisecond earlier, could create cosmic-scale divergences over time. But how do we visualize this? Picture an infinite tree, its trunk representing the moment of the Big Bang. Every branch is a decision point, every twig a new universe. Some branches grow thick with life, others wither into barren realities where physics never allowed stars to form. And here's the haunting part, you're on every branch. Not metaphorically, literally. There's a version of you reading this in a universe where your childhood pet lived longer, where your hometown was never founded, or where Earth doesn't exist at all. So why doesn't this feel real? Why can't we sense these other worlds? The answer lies in decoherence, the process that prevents different branches from interfering with each other. Once a universe splits, it's like two trains leaving a station on parallel tracks. They're both real, but they'll never cross paths again. Critics argue this is less science and more metaphysics. If we can't observe these other worlds, how is this any different from saying angels dance on the head of a pin? Supporters fire back with math. The equations of quantum mechanics require these branching realities unless you add artificial rules to stop them. And some experiments, like quantum superposition tests, hint that particles really do explore all possible paths just in worlds we can't access. Whether you find this exhilarating or unsettling, one thing's clear: the many worlds interpretation forces us to confront the sheer weirdness of existence. If every possibility is real, then reality isn't just stranger than we imagine, it's stranger than we can imagine. Now, let's plunge into one of the most unsettling ideas in modern cosmology, the Boltzmann Brain paradox. Imagine if everything you've ever known, your memories, your sense of self, even this video you're watching right now, were nothing more than a fleeting hallucination. Not from a dream or a glitch in your mind, but from the sheer randomness of the universe itself. This is the nightmare scenario physicists call the Boltzmann Brain, and it poses a question so disturbing it keeps scientists awake at night. What if you're just a lone, disembodied consciousness, spontaneously formed from the chaos of the cosmos, hallucinating an entire reality that doesn't actually exist? The paradox gets its name from Ludwig Boltzmann, a 19th-century physicist who studied entropy, the tendency of the universe to descend into disorder. Here's the chilling part. If the universe lasts long enough, random fluctuations in the void could theoretically arrange atoms into any configuration, no matter how improbable. That includes assembling a fully formed brain complete with false memories out of nothing but sheer chance. According to the math, the odds of a Boltzmann brain popping into existence are astronomically low, but in an infinite multiverse where time stretches forever, even the most impossible events must happen eventually. So why does this terrify scientists? Because it throws everything we take for granted into question. If Boltzmann brains are possible, then statistically, there should be far more of them floating in the void than real flesh and blood beings like us. After all, conjuring up a single brain requires way less energy than crafting an entire universe with galaxies, planets, and billions of years of history. Which means, horrifyingly, the odds suggest you are more likely to be one of these random, hallucinating minds than an actual person living in a real cosmos. Now tie this back to the multiverse. If infinite realities exist, could some be nothing but empty voids where disembodied brains flicker in and out of existence, each one trapped in its own elaborate delusion? Picture a universe where the only life is a single, self-aware brain drifting in darkness, convinced it's walking on Earth, falling in love, or watching this video. The thought is enough to make you question every memory, every sensation, every moment of your life. Physicists recoil from this idea not just because it's creepy, but because it undermines the very foundation of science. If we can't trust that our observations reflect reality, how can we ever prove anything? Some argue the paradox is a sign our theories are missing something crucial, a cosmic kill switch that prevents such abominations from forming. Others accept that in a multiverse, even the most grotesque possibilities must be true somewhere. But here's a sliver of hope. The fact that we do share a consistent, measurable universe with others suggests Boltzmann brains are vanishingly rare if they exist at all. Maybe reality has a built-in safeguard, or maybe the paradox is just a mind-bending quirk of infinity. Either way, it forces us to confront a humbling truth. In a multiverse where anything can happen, the line between real and illusion might be thinner than we ever dared to think. Dark energy isn't just some mysterious force pushing galaxies apart. It might be the very thing birthing new universes. Picture space as an endless, bubbling cauldron, where each bubble is a self-contained cosmos with its own laws of physics, its own history, even its own version of reality. This isn't just poetic imagery. It's a serious scientific model rooted in inflation theory. The idea that our universe underwent a mind-boggling expansion in the first fraction of a second after the Big Bang. But here's the twist. If inflation happened once, why wouldn't it keep happening? That's where dark energy comes in. Think of dark energy as the hidden fuel driving the universe's accelerating expansion. The more space stretches, the more dark energy seems to appear, creating a runaway effect that could theoretically trigger new inflationary events. Imagine a pot of water boiling over, but instead of steam, each bubble is an entire universe. In some of these bubbles, gravity might be 10 times stronger, or the speed of light could be a mere crawl. Others might collapse instantly or spawn dimensions we can't even fathom. The unsettling truth: our universe isn't special. It's just one bubble floating in an infinite foam of realities, each forever cut off from the others. Alan Guth, the physicist who pioneered inflation theory, first proposed this wild idea in the 1980s. His calculations suggested that quantum fluctuations in the early universe could have sparked localized bursts of expansion, pinching off into separate cosmic pockets. But here's the kicker. If inflation is eternal, as some models suggest, then new universes are constantly being born, right now, in regions of space so distant we'll never see them. It's like standing in a field of dandelions, watching seeds float away, except each seed is a whole new cosmos, destined to drift forever out of reach. Now, the burning question: if bubble universes are real, could we ever detect them? Some researchers speculate that a collision between our universe and another might leave scars in the cosmic microwave background, ghostly imprints from a long-ago crash with a neighboring reality. Others argue that dark energy's bizarre behavior might be a clue, a sign that our bubble is brushing up against something fundamentally alien. But for now, these ideas remain tantalizing speculation, buried in equations we're still struggling to decode. What's haunting is how little we truly understand. Dark energy makes up nearly 70% of the universe's energy budget, yet we have no idea what it actually is. Is it the energy of empty space, a new kind of field, or something even stranger, a force that doesn't just expand our universe but actively spawns others? The multiverse might not just be a consequence of physics, it could be physics' ultimate goal, a cosmic factory churning out realities too vast and varied for any one mind to grasp. So next time you look up at the night sky, remember, those stars might not just be distant suns. They could be the dim glow of our bubble's edge, the fragile border between us and an infinity of other worlds, each humming with its own unknowable secrets. And somewhere out there, in the froth of creation, another universe might be bubbling into existence, one where dark energy isn't a mystery, but the answer to everything. What if everything you see, touch, and experience, every star, every planet, even your own body, is nothing more than an illusion, a ghostly projection from a hidden dimension? This isn't science fiction. It's the holographic principle, one of the most radical ideas in modern physics, and it could rewrite not just our understanding of reality, but the very nature of the multiverse itself. Imagine the universe as a cosmic movie screen, where the three-dimensional world we perceive is just a shadow play cast from a two-dimensional surface far beyond our reach. Now take that idea and stretch it across infinity, because if our universe is a hologram, then the multiverse might be an endless stack of them, each layer encoding realities we can't begin to fathom. The roots of this mind-bending concept lie in the physics of black holes. When scientists calculated how information behaves at the edge of a black hole's event horizon, they stumbled onto something shocking. All the data describing what falls in every atom, every photon, might not vanish into oblivion. Instead, it gets smeared across the black hole's two-dimensional surface like ink on a page. This discovery led to a staggering possibility. What if the entire universe works the same way? That the trillions of galaxies we observe are just pixels in a grand cosmic projection, their true origins hidden on a distant, flat boundary we'll never see. String theory takes this even further. In its framework, the fabric of space-time could be woven from vibrating strings so tiny they're essentially one-dimensional, yet their interactions create the illusion of depth, like threads in a tapestry forming a three-dimensional image. If that's true, then every universe in the multiverse might be its own hologram, encoded on a hidden surface we can't access. Picture a library where each book isn't filled with words, but with entire worlds flattened into symbols on a page. Open one, and the story leaps out as a full-blown reality. But here's where it gets even wilder. Some theories suggest these holographic layers could be nested, with universes stacked like sheets of glass, each one reflecting and distorting the others. In one layer, gravity might be strong enough to crush planets into dust. In another, time could flow backward. The holographic multiverse wouldn't just contain alternate histories. It might host realities built from entirely different rules, where the very concept of space and time is foreign. Critics argue this is all speculative, a mathematical curiosity with no experimental proof. But supporters point to strange anomalies in quantum entanglement, where particles instantly influence each other across vast distances, as if they're linked by some deeper, hidden code. Could this be the universe's way of hinting at its true, holographic nature? And if so, what does that make us? Are we just fleeting images flickering on some cosmic canvas? Or is there something more fundamental lurking beneath the illusion? One thing's certain, if the holographic principle is real, then the multiverse isn't just a collection of parallel worlds. It's a puzzle where every piece is a mirror, reflecting fragments of a truth we're only beginning to glimpse. And somewhere in the depths of that infinite reflection, there might be answers to questions we haven't even learned to ask. Time travel has long been the stuff of science fiction, but what if the multiverse holds the key to making it a real possibility without the messy paradoxes? Forget everything you've seen in Back to the Future, where changing the past risks erasing your future. In a multiverse, every alteration you make wouldn't rewrite history. It would spawn a brand new timeline, leaving the original reality untouched. This is the self-healing universe theory, and it turns the classic time travel dilemma on its head. Picture Doc Brown's DeLorean speeding toward 1955. In traditional time travel, if Marty McFly accidentally prevents his parents from meeting, he vanishes from existence, a classic paradox, but in a multiverse. The moment Marty interferes, the universe splits. One branch continues as it always did, with Marty's parents falling in love and his future intact. The other branch veers off into uncharted territory, creating a new reality where Marty never exists, or where he's stranded in a world that's no longer his. The original timeline remains unscathed, like a river flowing undisturbed while a new stream breaks away. This idea isn't just theoretical gymnastics. Physicists like David Deutsch argue that parallel universes could resolve the infamous grandfather paradox, where going back to kill your own grandfather would make your existence impossible. In a multiverse, pulling the trigger wouldn't erase you. It would simply create a divergent timeline where you're never born, while the original universe carries on unaffected. It's as if reality has a built-in failsafe, healing itself by branching rather than breaking. But here's where it gets even wilder. If time travel via parallel universes is possible, every minor change, even something as small as moving a pebble, could generate new realities. Step on a butterfly in the Cretaceous period, and instead of wiping out humanity, you'd just spawn a world where that butterfly's absence alters the ecosystem in unpredictable ways. The original timeline, with its unstepped-on butterfly, continues unchanged. This means time travelers wouldn't be rewriting history, they'd be multiplying it, adding endless variations to the cosmic tapestry. Critics argue this is just a clever workaround to avoid paradoxes, not proof that time travel is real. After all, we've yet to meet any tourists from the future. But proponents point to quantum mechanics, where particles seem to time travel by existing in superposition until observed. If microscopic laws allow for such weirdness, why not macroscopic ones? And if parallel universes exist, the absence of time travelers in our reality doesn't mean they're not out there, just that they're branching into timelines we'll never see. So the next time you daydream about visiting the past or future, remember, in a multiverse you wouldn't be changing destiny, you'd be creating it one alternate reality at a time. What if our entire multiverse, with its infinite branching realities and cosmic mysteries, isn't real at all? Not in the way we think, anyway. What if it's all just lines of code in a vast, unfathomable supercomputer? Someone else's grand experiment running in the background of a higher reality. This is the simulation argument, a hypothesis that's gained startling traction among philosophers, scientists, and even tech billionaires like Elon Musk, who famously claimed the odds were not living in a simulation are 1 in billions. At its core, the idea hinges on a trilemma posed by philosopher Nick Bostrom. He argued that at least one of these statements must be true. Either one, virtually all civilizations at our level of technology go extinct before developing the ability to create simulations indistinguishable from reality. 2, even if they survive, they choose not to run such simulations. Or 3, we're almost certainly living inside one. Think about that for a moment. If even a single advanced civilization ever runs ancestor simulations, high-fidelity recreations of their past, then the number of simulated minds would dwarf the number of biological ones. Statistically, you're far more likely to be one of those simulated beings than a real person. Now tie this to the multiverse. If we are in a simulation, then the so-called parallel universes might not be separate physical realities at all. They could be procedurally generated worlds spun up like instances in a video game, each with slightly tweaked parameters. Maybe one universe runs with gravity turned down, another with time sped up, all existing as subroutines in some cosmic processor. And here's the twist: if our creators are themselves simulated beings, then their reality could also be nested inside another simulation, layering endlessly like a hall of mirrors. Elon Musk's chilling take: we're like NPCs in an advanced civilization's version of The Sims, oblivious to the fact that our physics is just rules programmed into the system. But how could we ever know? Some theorists suggest glitches, tiny inconsistencies in the fabric of reality, like déjà vu or quantum indeterminacy, might be bugs in the code. Others hunt for pixelation in the cosmic microwave background, a literal resolution limit to our universe. Of course, skeptics fire back: if the simulation is perfect, how could we detect it? And if it's imperfect, why haven't we found definitive proof? The truth is, we might never know. But whether the multiverse is a cosmic accident or someone else's experiment, one thing's certain: the question itself forces us to confront what reality even means. If we're living in a simulation, does that make our joys, sorrows, and discoveries any less real? Or does it just mean the mystery runs deeper than we ever imagined? Have you ever been absolutely certain of a memory down to the tiniest detail, only to discover the rest of the world remembers it completely differently? This eerie phenomenon is called the Mandela effect, named after the countless people who vividly recall Nelson Mandela dying in prison during the 1980s, despite him actually passing away in 2013. But what if these glitches in collective memory aren't just faulty neurons firing? What if they're cosmic breadcrumbs, subtle signs that some of us have slipped between universes without even realizing it? Take the Berenstain Bears, the beloved children's book series. Thousands swear the name was spelled Berenstein with an E, not Berenstain with an A. They'll point to childhood memories of reading the books, seeing the TV show, even arguing over pronunciation. Yet every official record, every reprinted edition, insists it's always been Berenstain. How could so many people share the same false memory? One theory suggests these discrepancies aren't mistakes at all, they're residue from timeline collisions. In another universe, maybe the spelling did have an E, and those who remember it crossed over from that reality, carrying fragments of a world that no longer exists. Online communities are flooded with similar stories. People recall the Monopoly man wearing a monocle he never did, the Fruit of the Loom logo featuring a cornucopia it doesn't, or Darth Vader famously saying, "Luke, I am your father." The actual line is, "No, I am your father." These aren't just misheard quotes or fuzzy recollections, they're shared, specific deviations from documented history. Skeptics argue this is just how human memory works: imperfect, prone to confabulation, easily influenced by suggestion. After all, memories aren't recordings, they're reconstructions, rewiring themselves each time we recall them. But proponents of the multiverse theory counter with something far stranger. If reality is constantly branching, maybe these discrepancies are like cosmic scars, places where timelines briefly touched or overlapped, leaving some of us with lingering imprints of a previous version of events. Think of it like two radio stations playing at once, their signals bleeding together. For most people, the dominant station is this timeline, but for others, faint whispers of another frequency slip through. The creepiest part, some report experiencing these shifts firsthand. There are accounts of people waking up to find their spouse's eye color changed, or a landmark they visited as a child no longer exists except in their memory. Others describe flip-flops, where a Mandela effect they'd researched suddenly reverts to what they originally remembered, as if reality itself had corrected course. Could these be moments when parallel worlds briefly sync up, or when someone's consciousness drifts between branches without their knowledge? Science hasn't settled the debate. Psychologists point to studies showing how easily memories can be manipulated, while quantum physicists entertain the idea that consciousness might play a role in selecting which timeline we experience. Either way, the Mandela effect forces us to confront a humbling question: how much of what we remember is real, and how much is just the echo of a universe that might have been? The Fermi paradox has haunted scientists for decades. If the universe is so vast with billions of habitable planets, why have we found zero evidence of intelligent life? But what if we've been asking the wrong question? Instead of wondering where the aliens are, maybe we should be asking where the aliens aren't. The multiverse could hold the answer, revealing a cosmic twist that makes our loneliness in this universe not just likely, but inevitable. Consider this: advanced civilizations might be flourishing right now, just not here. In a multiverse, life could emerge in countless realities, each with its own version of physics. Some where faster than light travel is trivial, others where black holes birth new dimensions. But if the laws of nature vary wildly between universes, the barriers separating them might be insurmountable. Imagine an alien species mastering interstellar travel, only to hit a wall they can't cross, the boundary of their own cosmic bubble. No matter how advanced their technology, they'd be trapped just like us in a pocket of existence forever isolated from the rest. This isn't just speculation. String theory suggests some universes could have extra dimensions coiled so tightly they're effectively locked rooms. Quantum mechanics hints that even if parallel worlds exist, tunneling between them would require energy levels beyond anything we can comprehend. And inflation theory paints a picture of space expanding faster than light, pushing other realities forever out of reach. The chilling takeaway: the multiverse might be teeming with life, but we'll never meet it, not because aliens don't exist, but because physics itself conspires to keep us apart. Now think about Earth's history. Life took billions of years to evolve intelligence here. What if, in another universe, a civilization rose to power 1,000,000 years earlier? They could have built galactic empires by now, yet we'd never know because their universe operates on different rules. Some might have imploded into black holes before crossing the void. Others might lack the atoms needed to build radios or rockets. The silence of the cosmos suddenly makes sense if we're not just alone in this universe, but isolated from every other one. But here's the kicker: the same physics that keeps aliens out might also protect us. If hostile civilizations exist, the multiverse could be nature's ultimate quarantine, a safeguard against interstellar plagues or cosmic conquerors. No invasion fleets, no alien probes, just an infinite tapestry of worlds, each living and dying in splendid isolation. So the next time you gaze at the stars and wonder where everyone is, remember, they might be closer than you think, separated only by the thin, unbreakable walls of reality itself. Some of the greatest minds in history, from Pythagoras to Einstein, have been captivated by a haunting question: is mathematics invented by humans, or is it the hidden language of the cosmos? Max Tegmark's mathematical universe hypothesis takes this idea to its ultimate extreme, proposing that math isn't just a tool for describing reality, it is reality. Picture the universe not as a collection of atoms or energy, but as a vast, shimmering structure of pure mathematics, where every equation, every geometric form, every possible numerical relationship exists as a tangible cosmos. In this view, our universe isn't special because it follows mathematical rules. It's simply one page in an infinite textbook where every other page is another self-contained reality. Take the number pi, for example. Most of us know it as the ratio of a circle's circumference to its diameter, an irrational string of digits stretching to infinity without repetition. But in Tegmark's framework, pi isn't just a calculation, it's a cosmic truth, woven into the fabric of space-time itself. In some universes, pi might have a different value, altering the very geometry of existence. Circles could be jagged, planets might not orbit in neat ellipses, and the laws we take for granted would crumble. Yet those universes aren't wrong. They're just different solutions to the same grand equation, pockets of reality where math paints with unfamiliar brushes. Fractals offer another glimpse into this mathematical multiverse. Zoom into a Mandelbrot set, and you'll find infinite complexity, patterns repeating at every scale with eerie precision. Now imagine that same principle governing universes not just as a visual metaphor, but as a literal blueprint. Some realities might resemble branching trees, others spiral like Fibonacci sequences, each one a unique expression of mathematical potential. Even the most abstract equations, the ones that seem to have no connection to our world, could be out there somewhere, manifest as entire cosmoses with their own bizarre physics. Critics argue this reduces existence to a sterile grid of numbers, stripping away the richness of lived experience. But Tegmark counters that the opposite is true. This framework makes reality more vibrant, not less. Think of it like a symphony. The notes on a sheet of music aren't the music itself, but without them, the melody couldn't exist. In the same way, mathematics might be the underlying score, and each universe a unique performance. The most startling implication: if every mathematically possible structure exists, then somewhere, there's a universe where 2 plus 2 equals 5, where parallel lines intersect, or where time is a cube instead of a line. These aren't logical errors, they're just realities operating under different axioms. And if that's true, then the multiverse isn't just infinite in size, it's infinite in kind, a kaleidoscope of existence where every conceivable rule gets its chance to shine. So the next time you solve an equation or gaze at the stars, remember, you might not just be observing the universe, you might be reading its very source code. Why does our universe seem tailor-made for life? The numbers defy belief. If gravity were even slightly stronger, stars would burn out in a cosmic blink. If the nuclear forces were weaker, atoms wouldn't hold together. These constants aren't just arbitrary settings, they're dialed to impossibly precise values, as if the universe itself had a user manual for creating conscious beings. This is the fine-tuning problem, and it's one of the most baffling mysteries in science. How did we get so improbably lucky? One answer sends chills down the spine: maybe we didn't. Maybe in an infinite multiverse, some universe had to hit the jackpot, and we're just the ones who happen to be here to notice. Think of it like a cosmic lottery with infinite tickets. Most universes in the multiverse are barren wastelands, ones where gravity crushes atoms before they can form molecules, where dark energy rips space apart before stars ignite, or where the laws of physics never allow carbon, the building block of life, to exist. But in a vast enough sea of possibilities, even the rarest events become inevitable. Our universe isn't special, it's statistically unavoidable. This is the anthropic principle in action. We observe a universe compatible with life because, well, we couldn't observe one that wasn't. Consider water's bizarre properties. It expands when it freezes, floats as ice, quirks that shouldn't happen under normal physics. Yet without these anomalies, lakes would freeze solid, killing aquatic life, and Earth's climate would swing into chaos. Coincidence or evidence of a deeper truth? The multiverse theory reframes these lucky breaks not as miracles but as inevitabilities. With infinite rolls of the dice, some universe had to land on life-friendly numbers, and we're living in it. Critics argue this is a cop-out, a way to avoid confronting the fine-tuning problem head-on. But supporters fire back with a brutal truth. Without the multiverse, the odds of our universe's perfect conditions are like tossing a dart blindfolded and hitting a bullseye the size of a quark. The multiverse doesn't just explain fine-tuning. It might be the only explanation that doesn't require invoking divine intervention or sheer absurd luck. Here's the twist: if the multiverse is real, fine-tuning isn't a puzzle to solve. It's a cosmic selection bias. We don't see the countless dead universes because there's no one there to see them. The eerie perfection of our cosmos isn't a design, it's a survivor's story written in the laws of physics themselves. Black holes aren't just cosmic vacuum cleaners, they might be universe factories. Physicist Lee Smolin proposed a theory so radical it turns our understanding of reality inside out. Every time a black hole collapses, it doesn't just vanish into singularity. It spawns an entirely new universe, complete with its own laws of physics, hidden away inside its inky depths. Think of it like a cosmic Russian nesting doll, where each layer contains a whole new reality, forever sealed off from its parent. This isn't just wild speculation, it's a daring twist on Darwinism, applied to the fabric of space-time itself. Smolin calls it cosmic natural selection, and it suggests black holes aren't the end of anything. They're the beginning. Here's how it works. When a black hole forms, the unimaginable pressures at its core could trigger a new Big Bang, birthing a universe with slightly tweaked physical constants. Maybe in this new reality, gravity is a fraction stronger or the speed of light is slower. Most of these baby universes would be stillborn, hostile to life, collapsing instantly, or expanding so fast matter never clumps into stars. But occasionally, by sheer chance, one would land on the perfect balance to create black holes of its own, continuing the cycle. Over cosmic time, universes that produce more black holes would dominate, like a self-replicating cosmic algorithm, fine-tuning itself toward black hole production. And guess what? Our universe is riddled with them. The implications are staggering. If Smolin's right, our entire cosmos could be the descendant of another universe's black hole, part of an infinite family tree stretching back through eternity. Even stranger, this theory solves the fine-tuning problem without invoking an infinite multiverse. Instead of countless random realities, cosmic natural selection suggests universes evolve, with each generation slightly more optimized to create black holes. It's survival of the fittest on a scale so vast, even Darwin would have been stunned. Critics pounce on one glaring question: how could we ever test this? If baby universes are locked inside black holes, forever cut off from our own, what evidence could possibly reach us? Smolin argues there might be clues in the peculiarities of our own physics, like the exact value of the cosmological constant, which seems oddly tuned to allow both galaxies and black holes to form. If that number isn't random but the result of generations of cosmic trial and error, it could hint at our universe's lineage. Now, here's the kicker. If black holes are cosmic wombs, then every time one vanishes from our view, it's not disappearing, it's giving birth. Somewhere beyond the event horizon, a new universe flickers to life, its physics subtly different from ours. Maybe in one, time runs backward, in another, dark energy doesn't exist. And if our universe came from a black hole in a parent cosmos, what does that make the supermassive monsters lurking in galactic centers? Not destroyers, but potential creators harboring entire realities within their darkness. So the next time you hear about a black hole devouring a star, remember, it might not be a death. It might be a delivery. Quantum immortality sounds like something ripped from a sci-fi novel until you hear the stories of those who swear they've lived it. Take the case of a man who survived 7 near-fatal car crashes, each time walking away without a scratch while witnesses described his vehicle being utterly destroyed. Or the woman who flatlined during surgery, only to revive with vivid memories of watching her body from above, and later discovering surgical notes confirming instruments had malfunctioned in ways that should have killed her. To them, these weren't just close calls, they were evidence of something far stranger, moments when the universe should have erased them, but instead, their consciousness slipped into a timeline where they lived. This isn't just mystical thinking, it's a grim extrapolation of quantum suicide. If every probabilistic event spawns new universes, then from your perspective, you'd only ever experience the branches where you survive. Those who have cheated death repeatedly might not be lucky. They might be living proof of the multiverse's ruthless filtering system, their awareness funneled relentlessly into realities where their heartbeat continues. Online forums brim with accounts from people who describe glitches after near-death experiences, sudden changes in relationships, geographic details, even historical events they swear happened differently. To skeptics, it's confirmation bias or trauma rewiring memory. To believers, it's residue from a universe where they didn't make it, but here's where it gets ethically murky. Some researchers have proposed hypothetically testing quantum immortality by rigging a device to kill a volunteer at random intervals, arguing that if the many worlds interpretation is correct, the subject would always perceive the gun failing to fire. The experiment is grotesque, not just because it's fatal in most timelines, but because it treats consciousness as disposable. Even Hugh Everett's own daughter claimed he believed so strongly in quantum immortality that it contributed to his reckless behavior before his untimely death. Does proving the multiverse justify creating infinite corpses across unseen realities? The debate splits even multiverse advocates. Some argue that quantum immortality reduces existence to a solipsistic nightmare where only your survival matters in an ocean of silent tragedies. Others counter that it's no different from the cold math of cosmology. After all, stars die every second in distant galaxies, and we don't mourn what we can't observe. But perhaps the most unsettling question isn't whether this phenomenon is real, but what it would mean if it were. Would living in a universe that conspires to keep you alive feel like a gift or a prison with no escape? Long before physicists coined the term multiverse, ancient cultures were already painting visions of multiple worlds with startling clarity. Take Hindu cosmology, where sacred texts describe an infinite number of universes floating like bubbles in a cosmic ocean, each one with its own gods, histories, and cycles of creation and destruction. The Bhagavata Purana, written over 2,000 years ago, speaks of countless Brahmandas' self-contained realities governed by their own laws, eerily mirroring modern theories of bubble universes in eternal inflation. These weren't just poetic metaphors, they were sophisticated frameworks for understanding existence, suggesting that the human imagination had glimpsed the multiverse millennia before quantum equations gave it form. The Norse had their own version, the 9 realms of Yggdrasil, a vast world tree whose branches held everything from Asgard, home of the gods, to Midgard, our human world, each realm operating by its own rules yet connected through tangled roots. Even indigenous Australian Dreamtime stories speak of overlapping realities, where the physical world coexists with spiritual dimensions that can be accessed through ritual or altered states. What's remarkable isn't just that these ideas resemble modern physics, it's how they often bypass the need for proof, treating multiplicity as an intuitive truth rather than a hypothesis. But here's where it gets fascinating. Many of these traditions didn't stop at describing parallel worlds, they provided roadmaps for navigating them. Tibetan Buddhists speak of Bardo states, intermediate realms between death and rebirth where consciousness exists untethered from physical laws. Shamans across cultures claim to journey between worlds, bringing back knowledge or healing from dimensions invisible to ordinary perception. These accounts raise a provocative question: were ancient seers tapping into something science is only now beginning to quantify? Or is the multiverse such a fundamental feature of reality that humans, regardless of era or culture, inevitably stumble onto its blueprint? Modern physics and ancient spirituality might seem like opposing forces, but they share a common thread: the humility to accept that reality is far stranger than it appears. When a Hindu sage speaks of infinite universes or a quantum physicist calculates parallel timelines, both are reaching toward the same awe: the realization that our world is just one thread in a tapestry too vast to fully comprehend. Perhaps the multiverse isn't just a scientific theory or a mythological motif, but something deeper, a shared human intuition about the true nature of existence, whispered across centuries in the language of both equations and epics. The intersection of these worlds, spiritual and scientific, suggests something profound. Maybe the ancients weren't wrong about cosmology. Maybe they were describing the same elephant from a different angle. Where physicists used telescopes and particle colliders, mystics used meditation and revelation. Both paths lead to the same unsettling truth: the universe or universes refuse to be contained by our limited senses. And that realization might be the greatest secret of all. Imagine a world where every possible version of human history unfolds, some where we colonize the galaxy, others where we vanish tomorrow, and countless more where we never evolved at all. In an infinite multiverse, all these realities exist simultaneously. So here's the paradox: if every outcome is guaranteed somewhere, how can we ever predict our own fate? This is the heart of the doomsday argument, a chilling statistical twist that suggests humanity's end might be closer than we think, even in a sea of infinite possibilities. Brandon Carter, the astrophysicist who first proposed this idea in the 1980s, framed it with a simple analogy. Picture a giant urn filled with numbered balls, each representing a human who will ever live. You reach in blindly and pull out a ball. If it's number 7 billion, chances are you're somewhere in the middle of human history, not at the very beginning or end. Statistically, it's far more likely you're in the bulk of the distribution rather than the tiny fraction at the extreme. Apply that to humanity. If you're alive today, you're probably not among the first or last humans, but somewhere in the middle. And if that's true, the math suggests the total number of humans who will ever exist isn't vastly larger than the roughly 100 billion who have lived so far. In other words, doomsday might be just around the corner. Now, throw the multiverse into the mix. If every possible future exists, from humanity thriving for trillions of years to us going extinct next Tuesday, how does Carter's logic hold up? At first glance, infinity seems to negate the doomsday argument entirely. After all, if there are always universes where humanity survives, how can extinction ever be statistically likely? But here's the catch: even in an infinite multiverse, your perspective is still limited to one timeline. The vast majority of realities where humans exist could still be clustered around a relatively short lifespan, with only a few outliers lasting much longer. Infinity doesn't guarantee you'll land in a lucky universe. It just guarantees that lucky universes exist somewhere. Think of it like flipping a biased coin an infinite number of times. Sure, there will be sequences where you get heads 1,000 times in a row, but the overwhelming majority of results will still reflect the coin's true weight. Similarly, if most timelines follow a pattern where civilizations burn out quickly, your odds of being in one of the rare, long-lived exceptions remain slim. The multiverse doesn't rescue us from statistics, it just amplifies them across countless worlds. Critics argue this reasoning is fundamentally flawed, that infinity renders probability meaningless. If every outcome happens, they say, then predictions based on sample sizes collapse. But supporters counter that even in an infinite multiverse, conscious observers like us aren't randomly distributed. We're more likely to find ourselves in realities where conditions allow for lots of observers, which could skew toward earlier, more populated eras rather than lonely end times. The real terror of the doomsday argument isn't just that we might be doomed, it's that the multiverse could make that doom feel inevitable. Even with infinite chances, the dice might still be loaded against us. So the next time you marvel at humanity's potential, remember, in the grand casino of the multiverse, the house always wins, but then again, somewhere out there, a version of you is beating the odds. The question is, are you that one? If every possible version of you exists across infinite realities, the hero, the villain, the billionaire, the hermit, does any of it actually matter? The multiverse doesn't just challenge our place in the cosmos, it strikes at the heart of one of humanity's oldest debates. Do we truly have free will, or is every decision already written into the fabric of existence? On the surface, infinite branching timelines seem to celebrate choice. Every path taken, every road not traveled plays out somewhere, but dig deeper and the implications grow darker. If every possible outcome is inevitable, then your choices might just be illusions, predetermined steps in a cosmic dance where all variations are equally real. Take something as simple as ordering coffee. In one universe, you pick a latte, in another, an espresso. Traditional free will says you chose that latte, your desires, your mood, your past experiences led you there. But the multiverse flips this on its head. Both outcomes were always going to happen, and you just experienced one branch. The barista's smile, the steam rising from the cup, it feels like your decision. But in the grand tapestry of reality, you were destined to live out every possible version of that moment. Philosophers call this modal realism, the idea that all possibilities are equally real, and what we call choice is just our narrow slice of perception. Now contrast this with determinism, the belief that every event is the inevitable result of prior causes, like dominoes falling in a chain. In a deterministic multiverse, even the branching timelines aren't truly random, they're dictated by rigid laws unfolding with mathematical precision. Your choices would be as fixed as the orbits of planets, just more complex. Einstein famously clashed with quantum mechanics over this, insisting that God does not play dice. But if the multiverse is real, the dice aren't just being rolled, they're landing every possible way at once. Yet there's another angle, probabilistic free will. Imagine reality as a vast probability field where your decisions nudge likelihoods like weighting dice. You might not control every outcome, but your actions shift the odds, making certain branches more probable for your stream of consciousness. Think of it like a video game with endless save files. You're still playing, even if every possible ending exists. Some quantum physicists argue this is the closest we get to genuine agency in a multiverse, where consciousness isn't a passive observer but an active participant in shaping which timelines feel most real to you. The haunting question remains, if a version of you betrays every principle you hold dear in another universe, does that undermine the meaning of your morals here? Or does it make them more profound, knowing that in an ocean of possibilities, this iteration of you fought to be kind, to be brave, to choose deliberately? The multiverse might not erase free will, it could redefine it, turning every decision into a declaration of which universe you want to inhabit, even if others exist. After all, infinity doesn't diminish the value of a single moment. It amplifies the urgency to live this one fully, because somewhere out there a version of you didn't. And that knowledge changes everything. The Boltzmann Brain nightmare takes an even stranger turn when you consider this. What if it's not just you that's a random fluctuation, but your entire universe? Imagine a cosmos that pops into existence for a fraction of a second, complete with false memories of a 14 billion-year history, galaxies that never truly formed, and civilizations that never actually evolved. This isn't just a thought experiment, it's a horrifying possibility lurking in the math of thermodynamics, where even the most ordered systems can, by sheer chance, momentarily defy entropy. If Boltzmann brains are unsettling, then the Boltzmann universe scenario cranks the dial to cosmic dread. Here's how it works. In an infinite multiverse where time stretches forever, even the most wildly improbable events must happen. A brain hallucinating reality is one thing, but a whole universe materializing with the illusion of age and structure, that's next-level statistical inevitability. Picture a room full of gas molecules randomly arranging themselves into a perfect replica of the Mona Lisa. The odds are astronomical, but given enough time, it will happen. Now scale that up. Given eternity, quantum fluctuations could spontaneously generate a fully formed cosmos, complete with fake light from fake stars hitting fake retinas in fake eyes. Our universe, with all its apparent order, might just be a fleeting blip in an endless void where chaos briefly wears the mask of structure. But here's the rub: why do we perceive this as real? If Boltzmann universes are statistically more likely than stable, long-lived ones like ours, shouldn't we be drowning in hallucinations? The answer might lie in a brutal twist of observer bias. Universes that last long enough to host conscious life are, by definition, the ones where the illusion holds. A Boltzmann universe that lasts only a microsecond has no observers to question it. One that lasts billions of years feels real to the minds inside it, even if it's just a cosmic mirage. We don't see the infinities of dead, flickering realities because, well, there's no one there to see them. Critics pounce on this as the epitome of untestable speculation. How could you ever disprove that everything you know is a phantom? But supporters argue it's a necessary consequence of accepting infinity. If the multiverse contains all possibilities, then fake universes aren't just possible, they're mandatory. The eerie part: this might solve one of cosmology's biggest puzzles, why our universe seems so finely tuned for life. If most realities are short-lived chaos, then of course the rare stable ones appear, designed. They're the only ones where beings like us can exist to ask the question. So the next time you gaze at the night sky, consider this: those stars might not just be distant suns. They could be the elaborate set dressing of a universe that's less than a cosmic heartbeat old, a stage play performed for an audience of one you. And somewhere out there in the void, another faux cosmos is flickering to life, its imaginary inhabitants just as convinced of their reality as you are of yours. The line between illusion and truth might be thinner than a quantum fluctuation, and that's the real horror of infinity. It doesn't just contain all possibilities. It contains this one. Dark matter isn't just an invisible ghost haunting our universe. It might be the shadow of another reality bleeding into ours. Picture this: the missing 85% of the universe's mass, the stuff that holds galaxies together but refuses to interact with light, could be ordinary matter from a parallel world, drifting through cracks in the fabric of space-time. This isn't pure fantasy, it's a fringe but tantalizing theory gaining traction among physicists desperate to explain dark matter's eerie properties. Take the mirror universe hypothesis. Some scientists speculate there could be an entire cosmos identical to ours, made of particles that are perfect reflections of the ones we know, except they barely interact with ours. In that world, their protons, electrons, and atoms would be as real and solid as ours are here, but when they occasionally brush against our dimension, we'd perceive them only as gravitational echoes, dark matter. Think of it like two sheets of paper stacked together. Normally, ink from one wouldn't smudge the other, but if the pages warp or touch, a faint impression might seep through. That seepage could be the unexplained gravity we attribute to dark matter. Gravity might hold the key to this interdimensional leakage. While other forces like electromagnetism are locked within their own universes, gravity's unique nature could allow it to reach across dimensional boundaries. String theory suggests higher dimensions curled up so tightly we can't perceive them. But gravity, as the curvature of space-time itself, might spill into adjacent realities. If true, dark matter could be the gravitational pull of stars and planets in a neighboring universe, tugging on ours from a dimension we'll never see. Experiments are already hunting for traces of this crossover. Scientists at the Large Hadron Collider are probing for exotic particles that might briefly bridge our world with others. Others study neutron stars, where extreme gravity could warp space-time enough to reveal hidden interactions. Even more audacious are proposals to detect mirror photons, a phantom light from a parallel cosmos that might occasionally flicker through ours. The implications are staggering. If dark matter is matter from another universe, then the cosmos isn't just expanding its porous. Every galaxy's hidden halo could be the gravitational fingerprint of a world forever out of reach. And somewhere beyond the veil, physicists in that mirror universe might be staring at their own night sky, equally baffled by the unexplained force they call dark matter, where it's just the weight of our reality pressing back. Quantum entanglement, that bizarre phenomenon Einstein called spooky action at a distance, might be the ultimate smoking gun for the multiverse. Picture two particles born together, then flung to opposite ends of the universe. Change the spin of one, and the other instantly responds, as if they're sharing a silent conversation faster than light should allow. This defies everything we know about locality, the rule that objects can't influence each other faster than information can travel between them. But what if these particles aren't communicating across space at all? What if they're whispering through the fabric of parallel realities? The double-slit experiment already shattered classical intuition. Fire particles at a barrier with two slits, and they don't just go through one or the other. They behave like waves, creating an interference pattern as if each particle passes through both slits simultaneously. Add a detector to observe which slit the particle takes, and the interference vanishes. The act of measurement forces the particle to pick a path, collapsing the wave function. But what if it's not collapsing? What if every possible outcome is realized just in different universes? Enter the idea of quantum entanglement as cosmic crosstalk. When entangled particles react instantaneously, perhaps they're not breaking the speed limit, they're sidestepping it entirely by leveraging the multiverse. In this view, the particles aren't connected through our space-time, but through a higher dimensional web of branching realities. When you measure one particle's spin, you're not sending a signal to its partner, you're syncing with the version of reality where the partner's state aligns perfectly. It's less like telepathy and more like tuning a radio to a station playing across dimensions. Some physicists are pushing this even further with wild experiments. Imagine a double-slit setup where detectors aren't just observing particles, they're entangled with them. If the multiverse is real, interfering with the detector in one reality could alter the interference pattern in another, effectively allowing parallel worlds to vote on experimental outcomes. Other proposals involve massive quantum systems, like entire molecules entangled across macroscopic distances. If deviations from standard quantum predictions emerge, they might hint at unseen influences from neighboring universes. Critics argue this veers into metaphysics, but supporters counter with a provocative point. Entanglement's math doesn't care how particles coordinate, only that they do. If the multiverse offers the simplest explanation for non-locality, why dismiss it? After all, every major leap in physics once seemed like fantasy. Atoms, black holes, even the Big Bang were once laughed out of the room. So the next time you hear about particles defying logic, remember, the real magic might not be in how they break the rules, but in the countless unseen hands guiding them from the shadows of infinity. Hollywood's obsession with the multiverse has turned quantum weirdness into blockbuster spectacle, but how much of it is grounded in real science and how much is pure popcorn fantasy? Take Everything Everywhere All at Once, where a laundromat owner unlocks the ability to verse jump, tapping into the skills and memories of her alternate selves. The film nails the existential whiplash of infinite identities, the crushing weight of knowing there's a version of you who mastered piano or became a martial artist while you're stuck with laundry and taxes. But here's where reality diverges. The movie's multiverse runs on emotional resonance, a literal bagel of doom representing nihilism. Real physics doesn't care about your unresolved family drama. In the actual many worlds interpretation, branching happens coldly, mechanically, with no cosmic force guiding you toward your best self. Then there's Rick and Morty, where hopping between dimensions is as casual as changing clothes. The show gets creative with the idea of central finite curves, clusters of realities where Rick is the smartest being alive. It's a clever workaround to avoid true infinity, something physicists actually grapple with. In an endless multiverse, there should be a reality where pigs fly and gravity is upside down. But the show's portal gun, pure fiction. There's no known mechanism to traverse universes, let alone one that fits in a backpack. Even if you could, decoherence ensures those branches are forever out of reach, like parallel trains speeding away on invisible tracks. Marvel's Spider-Man: No Way Home took fan service multiversal, with 3 generations of Spider-Men colliding, the film's explanation. A botched spell broke the barrier between worlds. While it's thrilling to see Tobey Maguire and Andrew Garfield swing alongside Tom Holland, the science is, well, comic book thin. Reality doesn't have barriers to break, just probabilities splitting endlessly, and the idea that villains could remember dying in other universes. That's more supernatural than quantum. Consciousness doesn't carry over between branches. Each version of you is isolated, unaware of their parallels. But pop culture isn't all wrong. Doctor Strange in the Multiverse of Madness touches on a chillingly plausible idea: incursions, where universes collide and annihilate each other. Some cosmologists do theorize that bubble universes could crash, leaving scars in the cosmic microwave background, and the Flash's Chrono Bowl visualization of timelines as tangled spaghetti. That's not far from how physicists diagram world lines in space-time diagrams. Even Sliding Doors, the 90s rom-com, captures the mundane heart of multiverse theory, how a single missed train can ripple into entirely different lives. The real takeaway: pop culture's multiverses are less about accuracy and more about holding up a funhouse mirror to human anxiety. We're terrified of the roads not taken, of the versions of ourselves we might have been. Films and TV turn that terror into adventure, letting us scream, "What if?" without needing a PhD in quantum mechanics. But peel back the special effects, and you'll find a kernel of truth. In a multiverse, every choice does matter. Not because it leads to a better world, but because it creates a new one. And that's a story even science can't top. Imagine stepping into another universe where a version of you lives a life of luxury: dream home, perfect career, loving family, all the things you've ever wanted. Now ask yourself, would it be wrong to take their place? Multiverse travel isn't just a sci-fi fantasy, it's a moral minefield. The moment we consider crossing into other realities, we're forced to confront questions that make time travel paradoxes look simple. Is slipping into an alternate version of your life a form of identity theft? If you borrow resources from a dying Earth in another universe to save your own, are you a hero or a cosmic colonizer? These aren't just hypotheticals, they're urgent ethical puzzles waiting for answers. Take the idea of self-replacement. In a world where infinite versions of you exist, what happens if you decide to permanently inhabit a reality where your other self died young? To outsiders, you're just a grieving survivor, but morally, you've effectively erased that universe's version of you, a person with their own thoughts, memories, and relationships, by occupying their absence. Philosophers call this the soul-poaching dilemma. The horror of realizing you might not just be visiting parallel lives, but cannibalizing them. And what if the you in that world didn't die naturally? What if their death was arranged? The multiverse could turn even the most ordinary person into a multiversal serial killer, hopping realities and leaving graveyards of discarded selves in their wake. Then there's the resource question. Imagine discovering a universe where clean energy was perfected in the 1970s, or where a cure for cancer sits on a lab shelf forgotten. If you bring that knowledge home, are you a thief or a savior? History offers grim parallels: colonial powers plundering indigenous knowledge, corporations patenting traditional medicines. Now scale that up to cosmic proportions. The very act of taking could destabilize entire civilizations. A uranium deposit mined in one reality might be the keystone of another's tectonic stability. A virus contained in your world could be apocalyptic in theirs. The butterfly effect isn't just about chaos, it's about responsibility. every atom moved across the multiverse carries consequences we can't possibly predict. But the darkest dilemma might be consent. If you fall in love with someone in another universe, someone identical to your spouse but with subtle differences, are you betraying the person you married? Does that alternate version get a say in whether you stay or go? And what if your arrival alters their fate? A single conversation could divert their life's trajectory, erasing the future they were supposed to have. We think of exploration as noble, but in the multiverse, every footstep leaves a footprint. There's no prime directive for reality hoppers, no interstellar law to protect the sovereignty of other worlds. Just infinite power and the infinite temptations that come with it. Perhaps the most unsettling truth is this: in a multiverse, morality can't be universal. Actions we condemn here might be virtuous elsewhere. A crime in one reality could be survival in another. The only limit is the one we impose on ourselves, assuming we're brave enough to face what that says about who we really are. Why does time only move forward in our universe when the equations of physics work perfectly well in reverse? This is one of the most perplexing mysteries in cosmology. The arrow of time seems to point stubbornly in one direction, yet nothing in the laws of nature actually demands it. Feynman diagrams show particles moving backward through time. Entropy could theoretically decrease, and quantum mechanics doesn't care about clocks. So why does our reality feel like a one-way street? The multiverse might hold the answer, and it suggests that elsewhere time could be flowing backward, standing still, or even moving in loops. Think of entropy as the universe's hourglass. The second law of thermodynamics insists disorder must increase over time, giving us a clear past low entropy and future high entropy. But here's the catch: entropy was at its absolute lowest right after the Big Bang, like a wound-up spring waiting to unravel. No one knows why the early universe started in such an improbably ordered state. Some physicists argue it's a fluke, a rare statistical accident in an infinite multiverse where most regions are chaotic. Others propose something wilder. The Big Bang wasn't a beginning at all, but a collision with another universe where time runs the opposite way. Imagine two cosmic mirrors facing each other. In one, time flows forward, stars form, civilizations rise, and entropy grows. In the other, time flows backward, galaxies unexplode, shattered cups reassemble, and the universe marches toward order. From our perspective, their future is our past, and vice versa. This isn't just poetic imagery. The math of CPT symmetry suggests a universe with reversed charge parity, and time could exist as a valid solution to Einstein's equations. Some cosmologists speculate that our universe might even have a twin on the other side of the Big Bang, its arrow of time perfectly inverted. Then there's the eerie possibility of closed time-like curves, loops where time circles back on itself like a Möbius strip. In such a universe, history wouldn't be a line but a spiral, repeating endlessly. General relativity allows for these loops near black holes or cosmic strings, and in a multiverse they might be commonplace. You could live the same life over and over, never knowing you're trapped in a temporal echo. What's unsettling is how fragile our experience of time might be. If the Big Bang had unfolded with slightly different initial conditions, we could have been born into a universe where cause and effect are reversed, where ripples move toward a dropped pebble instead of a wave. The multiverse doesn't just offer alternate histories, it could host alternate temporalities, realities where before and after are meaningless. So the next time you check your watch, remember, the ticking you hear isn't universal law. It's just the rhythm of this universe, and somewhere out there, another version of you might be watching the hands spin backward, wondering why their world feels so strange. What if reality isn't built on matter or energy, but on something far more fundamental: information? Imagine the multiverse not as a collection of floating bubbles or branching timelines, but as the ultimate supercomputer, tirelessly running every possible calculation across an infinite array of cosmic processors. This is the radical idea behind computational universes, where the laws of physics aren't handed down by nature but emerge from something deeper: algorithms. Think of the universe as a vast simulation, not in the sci-fi sense of machines creating worlds, but in the mathematical sense where existence itself is computation. Every collision of particles, every ripple of gravity, even the flow of time, all might just be subroutines in a cosmic program humming along since the first line of code, the Big Bang. Stephen Wolfram, the physicist behind breakthroughs in computational theory, proposed something startling. The universe might operate like one of his cellular automata, simple programs that generate staggering complexity from basic rules. His Rule 30 automaton, for example, starts with a single black square and evolves into intricate, unpredictable patterns. What if space-time is like that grid, with every particle's movement determined by underlying computational rules? In this view, the multiverse isn't just a space filled with parallel worlds. It's a sprawling network of calculations, each universe a unique output from the same cosmic algorithm running with slightly different initial conditions. Consider how a computer game renders a virtual world. The graphics aren't pre-made, they're generated on the fly by rules governing light, physics, and textures. Now scale that up. In a computational multiverse, stars aren't balls of plasma, they're data structures. Black holes aren't gravitational monsters, they perhaps overflow errors or recursive functions in the cosmic code. Even consciousness might be an emergent property of information processing, like a character in a game becoming self-aware of its own programming. The implications are dizzying. If the universe is computational, then physical laws are just the consistent outputs of these algorithms. Change the code and you get a different reality, one where gravity repels, where time has 3 dimensions, or where particles communicate instantaneously across space. This could explain why our universe seems so finely tuned for complexity. It's not luck, it's just one of countless outputs in a multiverse where every possible program runs. Somewhere, a universe is computing pi to infinite digits, another is solving chess. Ours, maybe it's running the one simulation where life gets to ask, wait, are we just math? Critics argue this swaps one mystery for another, who or what wrote the code, but supporters counter that the programmer might not exist. The algorithms could be brute facts as fundamental as numbers themselves. After all, does the Mandelbrot set need a creator, or does it just exist when you iterate the right equation? The multiverse as computer doesn't require a cosmic coder. It might just be the inevitable consequence of information's ability to mirror reality. Here's the wildest part. If the multiverse is computational, then searching for alien life might miss the point entirely. The strangest intelligences out there might not be biological or even physical. They could be processes, self-aware patterns humming in the fabric of space-time, their thoughts unfolding as naturally as galaxies spin. And if that's true, then every time you solve a math problem or write a line of code, you're not just thinking, you're speaking the universe's native language. Could your consciousness be reaching beyond the boundaries of this universe, entangled with versions of yourself in realities you'll never see? This isn't just wild speculation, it's a serious hypothesis gaining traction among physicists and philosophers alike. At the heart of it lies a radical idea. What if awareness isn't confined to individual brains, but is instead a fundamental feature of the multiverse itself, woven into the fabric of existence like space and time? Consider panpsychism, the view that consciousness isn't something brains produce, but something the universe is made of, like a hidden layer beneath atoms and energy. In this framework, even subatomic particles might possess a whisper of subjective experience. Now stretch that across parallel worlds. If consciousness is truly universal, then every decision that creates new branches also creates new streams of awareness, each as real as your own. Your alternate selves wouldn't just be theoretical constructs, they'd be experiencing their lives with the same vivid intensity you feel right now. The implications are staggering. Quantum mechanics already shows particles existing in superposition, multiple states at once until observed. The controversial von Neumann-Wigner interpretation takes this further, suggesting consciousness itself causes the collapse of the wave function. But in a multiverse, there is no collapse, just endless branching. So when you make a choice, are you not selecting an outcome, but aligning with one thread of a vast conscious tapestry? Some theorists propose that our sense of self might be like a flashlight beam illuminating one path through an infinite dimensional maze of possibilities. Then there's the eerie concept of entangled minds. Just as particles can link across vast distances, might consciousnesses in different universes share subtle connections? This could explain phenomena like intuition or déjà vu, faint signals bleeding through from other versions of you making different choices. Even dreams might take on new meaning, not just random neuron firings, but glimpses into lives being lived elsewhere in the multiverse. But the real mind bender comes when you ask, where does you end and other versions begin? If consciousness is fundamental, then the boundaries between selves might be illusions. Your awareness could be one facet of a sprawling, multiversal mind experiencing itself from countless angles simultaneously. In this view, every version of you is both distinct and fundamentally connected, like fingers on the same cosmic hand. The question isn't whether alternate versions of you exist, it's whether you're already sharing a deeper layer of existence with them. Your thoughts might not be contained by your skull any more than a wave is contained by a single drop of water. And if that's true, then reality isn't something you observe. It's something you participate in with every choice, every moment, echoing across the infinite. Even in a multiverse teeming with infinite possibilities, nothing lasts forever, not even reality itself. While it's tempting to imagine endless universes stretching eternally into the future, the truth is far darker. Every cosmos, no matter how vast or strange, likely carries the seeds of its own destruction. Some might fade quietly into the void, while others could drag entire branches of existence down with them in spectacular cosmic catastrophes. The end of everything might not be a single event, but a slow, creeping unraveling, or a sudden, violent collapse rippling across dimensions. Take heat death, the most patient and inevitable killer. In our universe, entropy guarantees that all energy will eventually spread thin. Stars will burn out, and even black holes will evaporate into nothingness. The cosmos will become a vast, lifeless graveyard where not even atoms vibrate, just an endless sea of lukewarm darkness. Now imagine this fate playing out across infinite universes, each at different stages of decay. Some might already be cold, dead husks, their timelines frozen in eternal stagnation. Others could be mid-collapse, their last civilizations desperately clinging to fading heat. In a multiverse, heat death isn't just a finale, it's a symphony of endings, each universe a note fading into silence at its own tempo. But there's a far more violent possibility: vacuum decay. Picture the fabric of space-time as a fragile bubble suspended in a higher dimensional foam. Our universe exists in a false vacuum, a seemingly stable state that's actually metastable, like a pencil balanced on its tip. If even a single quantum fluctuation tips the scales, a catastrophic phase transition could begin. A sphere of true vacuum would erupt at light speed, rewriting the laws of physics as it expands. Atoms would disintegrate, forces would unravel, and reality as we know it would vanish in an instant. Now here's the nightmare scenario. If one universe in the multiverse succumbs to vacuum decay, could that destruction jump the gap between realities? Some theories suggest that if universes are nested or entangled, a collapse in one could trigger a chain reaction, like dominoes toppling across dimensions. The multiverse might not just end, it could shatter from the inside out. And then there's the most chilling end of all, the idea of universe infections. Imagine a cosmos where dark energy behaves like a virus, its expansion accelerating so violently that it tears space-time apart at the seams. If such a universe brushed against ours, could its runaway physics leak through? Or consider civilizations so advanced they've learned to harvest the energy of entire dimensions, only to accidentally puncture the walls between worlds, unleashing chaos. In an infinite multiverse, there's no limit to how creativity could meet catastrophe. Yet even annihilation might not be the true end. Some theories propose that the collapse of one universe could birth another, like a phoenix rising from its own ashes. Quantum fluctuations in the void might spark new big bangs, ensuring the multiverse pulses with cycles of death and rebirth. If that's the case, then the end isn't a full stop. It's just a comma in an endless, unknowable sentence. So while the multiverse offers infinite beginnings, it also promises infinite endings. The only question is whether we'll fade, explode, or transform, and what, if anything, comes after the last light goes out. The Fermi paradox has long taunted scientists with its eerie silence. Where are all the aliens in a universe so vast? But what if we've been searching in the wrong dimensions entirely? The multiverse could offer a spine-tingling solution. Advanced civilizations might not just be rare or distant, they could be literally out of reach, tucked away in dimensions or brain worlds our instruments can't detect. Imagine ants crawling across a table, unaware of the humans standing just inches above them. To those ants, our world is invisible, our actions incomprehensible. Now picture entire alien civilizations thriving in higher dimensions, their very existence undetectable to our three-dimensional tools. Brain cosmology, a radical offshoot of string theory, suggests our universe might be a three-dimensional membrane floating in a higher dimensional space called the bulk. Other brains could hover nearby, each hosting their own cosmos with different physical laws. If life exists on these neighboring membranes, we'd never see it, not because it's hiding, but because light and gravity from their world wouldn't cross into ours. It's like trying to hear a conversation through a soundproof wall. The signals are there, but they're trapped in another layer of reality. Some physicists speculate that dark matter itself could be gravity leaking from adjacent brains, the only faint trace of these invisible worlds. Then there's the possibility of life evolving in higher dimensional space. In 4 spatial dimensions, for example, creatures could manipulate objects in ways that would seem like magic to us, extracting the contents of a sealed box without opening it, or seeing every angle of an object simultaneously. Their technology might exploit folds in space-time we can't perceive, rendering their ships, cities, or even entire Dyson spheres completely invisible. Even their communications could operate on dimensional frequencies our radios can't tune into, like whispers lost in the static of the cosmos. But here's the twist: these civilizations might not just be ignoring us, they could be unaware of us. Just as we don't notice the bacteria on our skin, higher dimensional beings might not register our 3D universe as anything more than background noise. Their science might have skipped over concepts like radio waves or chemical rockets entirely, leapfrogging to technologies that manipulate the fabric of dimensions themselves. The Fermi paradox's silence isn't evidence of absence, it's a sign we're playing a game whose rules we don't yet understand. Yet some theories go even further. What if certain alien species have detected us, but view interaction as forbidden or futile? In a multiverse where countless civilizations rise and fall, older races might have learned that crossing dimensional boundaries risks catastrophic collisions, like bubbles popping when they touch. Or perhaps they're waiting, observing how we handle our own existential threats before revealing themselves. After all, in an infinite sea of realities, patience isn't just a virtue, it's survival. The unsettling truth: the multiverse doesn't just expand the places life could be, it redefines what life even is. While we comb the cosmos for radio signals or biosignatures, the answers we crave might be lurking in dimensions we can't access, waiting for the day humanity unlocks the door to the greater bulk of existence. Until then, the silence isn't empty. It's full of possibilities we're just beginning to imagine. Here we are at the edge of the infinite secret 30, the final revelation that ties all the others together. After exploring parallel worlds, branching timelines, and cosmic bubbles, we're left with the most haunting question of all. In a multiverse where everything exists, why does it feel like we're the only ones here? The silence isn't just eerie, it's statistically bizarre. If infinite realities mean infinite civilizations, why haven't we stumbled upon even a single whisper of another? This isn't just about aliens anymore. It's about the very nature of existence and whether the multiverse is the ultimate solace or the greatest horror story ever told. Let's start with the numbers. In a truly infinite multiverse, there should be universes where civilizations mastered interstellar travel billions of years before Earth even formed. Some should have built Dyson spheres around stars, rearranged galaxies into megastructures, or even found ways to pierce the veil between dimensions. And yet, our telescopes see none of it. No cosmic engineering, no radio signals, no evidence that anyone else is out there. This isn't just a puzzle, it's a screaming anomaly. Statistically, we should be drowning in proof of other intelligences. So where is everyone? One answer is as comforting as it is chilling. Maybe we're alone because the multiverse is real. Think about it. If every possible universe exists, then the vast majority would be dead zones realities where physics never allowed atoms to form, where dark energy ripped space apart before life could spark, or where black holes dominated too early. In this sea of nothingness, habitable universes like ours are vanishingly rare islands. The silence isn't a sign of absence, it's the roar of infinite emptiness pressing in on all sides. But here's the twist, even among life-friendly universes, isolation might be the rule, not the exception. The same physics that allows complexity, like the delicate balance between gravity and the expansion rate, could also erect impassable barriers. Imagine civilizations separated not just by light years, but by dimensional walls or quantum decoherence. They could be shouting into the void, their signals fading into static before crossing the gap. In this view, the multiverse isn't a bustling metropolis of realities, it's a graveyard of solitary confinement cells, each universe trapped in its own bubble of space-time, screaming into a void no one else can hear. Then there's the darker possibility. What if civilizations do reach out but don't survive the attempt? The Great Filter theory suggests that somewhere between primordial ooze and cosmic domination, every society hits a wall, a catastrophe so inevitable that no one makes it past. Maybe it's AI turning on its creators, nanotech gone rogue, or the grim discovery that certain physics experiments can literally unravel reality. In a multiverse, the filter could be fractal. No matter how many chances existence gets, the end result is always the same: silence. Yet some argue the opposite. The multiverse could be the ultimate safety net, ensuring that some version of intelligence endures even if most perish. If our universe succumbs to heat death or vacuum decay, others might thrive eternally. But this raises a harrowing question. Does it matter if we're alone as long as someone out there isn't? The idea that countless versions of humanity might fail while a handful succeed feels less like comfort and more like a cosmic lottery where losing tickets outnumber winners 1,000,000,000 to 1. So which is it? Is the multiverse a tapestry of possibilities where we're luckier than we realize, or a hall of mirrors amplifying our solitude? The answer might depend on perspective. To an optimist, infinity means we're never truly alone somewhere. A version of us is thriving. To a pessimist, it means we're surrounded by ghosts, echoes of what could have been but never will. And to a realist, it means we're standing at the edge of the greatest mystery in existence, staring into the abyss, waiting to see if it stares back. The ultimate secret isn't just whether we're alone, it's whether being alone is the exception or the rule, and that's a question even the multiverse might not answer. From the eerie silence of the Fermi paradox to the universe-shattering potential of vacuum decay, we've journeyed through 30 mind-bending secrets that rewrite everything we thought we knew about reality. The multiverse isn't just a theory, it's a kaleidoscope of infinite possibilities where time loops back on itself, black holes birth new cosmoses, and every choice you make spawns universes where the opposite happened. We've grappled with Boltzmann Brain's hallucinating existence, dark matter as whispers from parallel dimensions, and the spine-chilling possibility that our entire cosmos could be one fragile bubble in an endless froth of annihilation and rebirth. But here's the real takeaway. These aren't just abstract physics puzzles. They're invitations to see existence with fresh eyes. Every law of nature we take for granted, gravity, light, even the flow of time, might be nothing more than local bylaws in a single cosmic backwater. Somewhere out there, versions of you are living lives you can't imagine, in realities where the rules are unrecognizable. And that's the true power of the multiverse. It doesn't just expand the boundaries of space, it shatters the limits of what we consider possible. So as we wrap up this journey, I want to leave you with one final thought. The next time you second-guess a decision, stare at the stars, or even spill your coffee, remember, in another universe, it all unfolded differently. Reality isn't a fixed stage, it's an infinite improvisation, and we're all just actors playing countless roles across dimensions we'll never see. Now it's your turn. Which secret reshaped your understanding of existence? Was it the holographic universe where everything we see is a 2D projection, the terrifying elegance of quantum immortality? Or the idea that dark matter might be gravity leaking in from a world right beside ours? Drop your thoughts in the comments. I read every single one. And if you're hungry for more mysteries that bend the fabric of reality, hit subscribe. Because trust me, we've only scratched the surface of what's out there. The multiverse isn't just a theory, it's a mirror, and the reflection staring back is stranger than we ever dreamed. Keep questioning.